everyone. Welcome back to Nature Nuggets, where we are talking about Maine's coastal habitat. Um, this video, I'm going to talk about one of these really cool, unique creatures that we can find here, which are horseshoe crabs. And what's really cool about them is they're what we call living fossils. So this creature has existed for more than 400 million years, which makes it even older than our dinosaurs. So it's been around longer than the time of the dinosaurs, and it hasn't really changed much. That means it's so well adapted that it hasn't needed to evolve further or change further. So we're going to take a quick look at these really cool creatures. So the first thing I want to point out is you might see these along the shoreline, especially at certain times of the year when they all come to the shallow coastal line to breed, to spawn, and they'll gather by the hundreds. So you might see some of these guys, and a lot of people think, bring it closer, they have this kind of spiny looking tail. A lot of people think that is something dangerous, that they sting. But they actually don't. All that tail is for if these guys accidentally flip themselves over, that tail is to push them back. So just to give you guys a better look at a horseshoe crab and what's underneath. So they have these 10 little legs here, right? And they kind of scurry along the shallow, along the bottom. And they will feed on pretty much anything that they can find. And if they were, like I said, to flip over, there's nothing really to help them turn over, right? They can't push themselves back. So that tail, they use the tail to hopefully flip themselves right ways. So these are really important to the ecosystem because of the large numbers in which they spawn, in which they lay eggs. Those eggs provide a really important source of nutrients that comes into the habitat, the ecosystem, every year. So, very ecologically important. The other reason horseshoe crabs are important is their blood. So, horseshoe crabs actually have blue blood. It's not red like ours. Their blood is more copper-based. And at some point, researcher decided to study it and found that that type of blood is really good at identifying bacteria and isolating it and combating it so that the horseshoe crab doesn't get sick. So the horseshoe crab has this tough outer skeleton, this exoskeleton, like what we learned with the insects, to help prevent it from predators or prevent predators from eating it. But the way that their body is set up leaves their underside pretty exposed. And there's a lot of bacteria that lives kind of in those coastal regions. So they had to have a really powerful way to combat that bacteria. And what their blood does is it kind of forms a bubble if it identifies anything that isn't supposed to be there, and kind of coagulates around it so it can't escape. So researchers found this and found that it was super useful for helping to test medical equipment. So if you've ever had a vaccine, which I hope you have, because they're very important, you benefited from horseshoe blood. So they test those vaccines on horseshoe blood to make sure that they're working properly. And they also use this to test a lot of medical equipment. So good for us. However, it has caused some issues with the horseshoe population. So they don't kill the horseshoes when they collect the blood. They collect the horseshoe themselves. They pull out some of the blood. They think they take up to 30% is what they're allowed to take. And then they re-release the horseshoe crab back in the wild. And for the most part, it shouldn't be harmful to them. However, if you imagine if you've ever given blood, if you kind of feel lethargic afterwards, that's because your body is working on replenishing that blood supply. Well, for female horseshoe crabs who are in the age range to breed, right, that blood loss can cause them to become lethargic, and then they don't come to the coastline as much in order to lay their eggs. So the collecting of the horseshoes has actually caused some of the populations to go down. And that's something that they're speculating about. Another threat, of course, like many other species, is habitat loss. So habitat loss and overcollection, both issues for these guys. So he's been around for over 400 million years. We should definitely want him to be around another 400 million more. All right. The other thing I wanted to do in this video, since we're talking about living fossils, is to show you guys some actual fossils that came from the ocean. So life originated in the ocean. The majority of our fossils are ocean-based creatures. And here are just a few common ones. Here we have a fossilized sea urchin. Right, very similar to a dried sea urchin that we might find in a gift shop today. Very similar body. The other one I wanted to point out is the ammonite here. And actually, I have a better specimen. This one of my own. So here's inside an ammonite shell. All right. And they look very similar to a creature that we still have today called a nautilus. So when they were alive, there was, picture, kind of an octopus-like creature that would live in this shell. So a nautilus, I don't have a picture, but I do have a puppet. Something like this. So they have their body inside the shell. So a lot of these fossils we find, which are from millions and millions of years ago, are either unchanged now or still have very similar species alive now, which is pretty cool. All right, so that's a little bit on fossils and our living fossil. In the next video, we're going to talk a little bit about sea stars and their family of animals.